to be talking to you about brain-computer interfaces. So this is a picture of what your brains look like right now. And to many of you, this probably looks like a bunch of squiggles on a piece of paper or on a computer. So what does this really mean? Well, there's some really cool stuff that we can do with this, and some of the really cool things that we can do is that we can actually use your brain signals to control computers. So this is what brain-computer interfaces are all about, using brain signals to control computers. But in order to really understand how this technology works, let's take a step back and look at your brains. So your brains are consisted of various neurons throughout your brains, as many of you probably already know. And every time you have a thought, that means that there's a different electrical pulse that's traveling through your neurons. And now every time each of these neurons has this electrical pulse which goes through them, we have something called an action potential taking place. Now, an action potential is a sudden change in the voltage of a neuron. So as you can see in the picture, we have this sudden increase in the voltage of the neuron, followed by a sudden decrease, where it finally rests into its resting potential. Now, when you're building BMIs and BCIs, you're looking for this sort of action potential, because by seeing the action potential, you're able to see whether or not these neurons were active or not. And so what can we do specifically with this? What can we do by looking for action potential? So we have various different technology where we can actually find this action potential, and we can transfer these to computers so you can then command the computers to do various different things. Now, one of these sorts of technologies is called neural dust. Now, neural dust is something which I'm really excited about because it's something that has been invented very recently by scientists at UC Berkeley, and is probably one of the most precise ways which we have in order to record your brain signals. So how neural dust works is that there are two main types. We have active nodes and passive nodes. So in active nodes, we have this huge piezoelectric crystal inside these neural dusts. And what happens is that this piezoelectric crystal receives an ultrasonic pulse from an interrogator, and it then converts this mechanical power from the pulse into electrical power so that it can take your brain signals and be able to process them and send them back to the interrogator itself. Then we also have passive nodes, which are very similar. However, these passive nodes, their main job is to just reflect this signal, so that now this signal can reach all parts of your brain where the neural dust is, and it's able to now send all this information from the active nodes back to the interrogator itself so that you can have all of this data. But this method is invasive, and so it's a lot harder to work with because you need to actually have surgery. However, we have another type of method called electroencephalograms, which is a non-invasive method of recording your brain signals. So with EEGs, you're able to record your brain signals by wearing just an electrode cap, and these electrodes are just looking, once again, for this action potential so that you're able to see whether or not your neurons are active, and then it can then go and command the computers to do various things. So in the past, we've had people wearing these really ugly caps in order to track whether or not their brain signals are working and to be able to see what brain signals you have. But recently, we've had developments such as the Muse Headset, which have been able to track your brain signals by wearing just this really comfortable piece of a headset that you can just put around your ears. So I decided that by looking at all these brain signals, I was like, oh, I want to see if I can do something about this, because all of this seems really cool, but can I really do something that can work with this BMI stuff? So I decided to make this thing where you can basically blink and then you can spell out words. So by looking for action potential, you're able to then make it so that the computer will actually go along these edges, along the columns, and you can select letters just by blinking. So once again, this uses the same sort of technology. I used the Muse headset in order to do it, but what I was doing was that I was taking and looking for these action potentials that occurs every time you blink, and then ordering the computer to then select the column and the rows in order to find the letters, which is really cool. But if I can do this, there's already been a lot of progresses in the field, which many of you probably haven't really heard about. So we've had things such as people being able to move robotic arms with just their brain signals, which is really cool if you think about it, especially in the medical field. Because now if we can have paralyzed people being able to move these arms, then it's a really huge improvement. But there's also a lot of places which this technology can go. And one of them is telepathy. Because imagine this, if you can have these brain signals and you can send them to another person which has this BMI in their head, they're able to then fuse this path which the neurons will take for this electrical pulse, and then you can be thinking the same thoughts as the other person. And I think this is probably one of the coolest things about BMIs, is the fact that we might even be able to take this to the extent in which we can have telepathy become a thing. And I'm not sure about you guys, but I would love to have some sort of telepathic communication with my friends. And so, because BMIs have some really cool implementations, and because we are already doing so much in the field today, I believe that this will have a huge impact on our future. Because if someone like me can build something like that, then imagine what scientists all across the world can do with their power. Thank you.